Today we're going to talk about proving quadrilaterals are parallelograms. And we have ways to prove that quadrilaterals are parallelograms. We can conclude that a quadrilateral is a parallelogram if both pairs of opposite sides are parallel, if both pairs of opposite sides are congruent, if both pairs of opposite angles are congruent, if an angle is supplementary to both of its consecutive angles, if the diagonals bisect each other, and lastly, if one pair of opposite sides is both parallel and congruent. If any of those occur, any one of those, then the quadrilateral is a parallelogram. So what I'd like us to do now is let's go to the next page, and what we're going to do is answer this question. Is the quadrilateral a parallelogram? All right, so here we know that one pair of opposite sides are parallel. Is that enough to say that a quadrilateral is a parallelogram? And the answer is no. We would need to know that either both pairs of opposite sides are parallel or that this one pair of opposite sides was also congruent. But all we know is that that one pair is parallel. So that's not enough. All right, next. We're given this parallelogram here, or I'm sorry, this quadrilateral here, and we want to know if it's a parallelogram. Well, if an angle is supplementary to both of its consecutive angles, it's a parallelogram. So for instance, let's look at 70 degrees. Its consecutive angles are 110, and 70 and 110 gives you 180, so those are supplementary. And its other consecutive angle is 110, and 70 and 110 is 180, making it supplementary. The other way, so we could use that idea to prove that this is a parallelogram. We could also use the idea that both pairs of opposite angles are congruent. So here are two different ways that we've looked at to say, yes, this is a parallelogram. Next picture. Is this figure a parallelogram? Well, if the diagonals bisect each other, it is. And that's clearly the case by the markings on the diagonals of this quadrilateral. So yes, because the diagonals bisect each other, it is a parallelogram. Lastly, you're given in this figure that one pair of opposite sides are parallel and the other pair of opposite sides are congruent. But is that enough? Well, according to what we were given, we said that we needed to know that one pair of opposite sides is both parallel and congruent. And we don't know that that is true of one pair. So this one's going to have to be a no. We don't have enough information to show that that's a parallelogram. Let's move on. You'll recall our slope formula, which is y1 minus y2 over x1 minus x2, or sometimes you put the y2 first and the x2 first. And the distance formula is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And we would like to use that information to see whether or not this figure is indeed a parallelogram. So what we're going to do, I'd like us to find the slopes and lengths of, and I've got to label these. I'm going to label these A, B, D, and C, like so. I'd like us to find the lengths of sides and the slopes of sides BD and AC, and then also do the same for CD and AB. By doing that, what we're trying to show, if this is indeed a parallelogram, that the opposite sides will have the same length, and if they're parallel, the slopes will be the same on the opposite sides. So let's take a look, first of all, at BD. Okay, let's look at the slopes. So here we have BD has the points, the endpoints 6, 5, and 7, 1. And if we plug them into our slope formula, which I'm going to write, that the slope is found by taking y2 minus y1 over x2 minus x1. It doesn't matter whether you put the x or the y first, as long as you're consistent. All right, so here's x1, y1, x2, y2. So we have m is equal to y2, which is 1, minus y1, which is 5, over x2, which is 7, minus x1, which is 6. So we end up with negative 4 over 1. Okay, so we know BD is parallel. Or no, I'm sorry, we don't know that. We want to see if BD is parallel to AC. So let's do the same thing with AC. Our points for AC are 1, 3, and 2, negative 1. So let's label our points x1, y1, and x2, y2. Plug them into our formula. So you have y2 is negative 1, minus y1, which is 3, over x2, which is 2, minus x1, which is 1. And we end up with negative 4 over 1. So sure enough, the opposite sides are parallel. In this case, BD is parallel to AC because our slopes are the same. Now, let's use the distance formula to see if indeed BD and AC have the same lengths. So here's your distance formula. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's plug our numbers in for BD first. Well, our numbers are listed right above here for BD. So we have the square root of, actually I'm going to move that over to the left just a little bit. Maybe I'll have room for both of them here. So I have the square root of x2, which is 7, minus x1, which is 6, squared, plus y2, which is 1, minus y1, which is 5, squared. So I end up with 1 squared plus negative 4 squared, which gives me 1 plus 16. So I get the square root of 17 is the length of BD. Now let's do the same thing and find the length of AC. Okay, so the length of AC. Now if we look up above here, see if I can move this thing over. Okay, if we look at AC, our points are right up above here. x1, y1 is 1, 3, and x2, y2 is 2, negative 1. So let's plug our numbers in. So we have 2 minus 1 squared plus y2, which is negative 1, minus y1, which is 3, all squared. So we end up with 2 minus 1 is 1 squared. Negative 1 minus 3 is negative 4 squared. This looks familiar. So we get 1 plus 16, and the length of AC turns out to be the square root of 17, so sure enough, they are the same length. So we know that BD and AC are parallel, because we figured out that they had the same slope up above, that they're parallel and congruent. Now remember, that's actually enough to prove that that figure right up here is a parallelogram. But what I would like you to do is try the other two sides. Try sides, let's see, what haven't we tried yet? AB and CD, and see if you can prove that those two sides are parallel and congruent as well, if you'd like a little extra practice. Thank you very much for joining me. So, oh, and before we conclude, let's just write down that that figure, AB, DC, is a parallelogram. So again, thank you for joining me. We'll see you next time.